Good day. Welcome back to our second lesson on Venn diagrams. In the previous one, we discussed Venn diagrams of two events. We're now going to expand it to Venn diagrams of three events. These problems are very important for grade 11 as well as for grade 12 exams. So let's look at the first problem and see how we're going to approach these Venn diagrams with three events. In this example, we read that there was a survey done on the technological devices that teenagers own. 150 teenagers were surveyed and the following results were obtained. 125 own cell phones, 47 own tablets, 58 own laptops. Then 40 own cell phones and laptops, 50 own cell phones and, that was tablets, this is laptops, 35 own tablets and laptops, and 30 own cell phones, laptops, and tablets. And they ask us in the first question to represent this on a Venn diagram. So let's start with a Venn diagram. Please take note, we do have three events here. And the three events are cell phones, tablets, laptops. So when we draw the Venn diagram, I'm going to use C for cell phones. So make sure that your sample space is a little bit bigger because we now need to put in three events here. So there's the first one, second one, and of course they intersect. So I'm going to use a C to represent cell phones, a T that represents tablets, and L that represents the laptops. Now, like we said in the two event Venn diagrams, we always start from the middle. So we need to, before we do anything, we need to know what this will be. So you need to go to your information and we want to know how many own all three devices that we will put in here. So let's see. When you look at this list, you will see that this 30 own cell phones, laptops, and tablets. So that is the one that we will put in the middle. So take note that we not necessarily follow this information from top down. We look what we want in a specific order. So we will, first of all, find all three devices. Then we're going to go for two devices and then one device that goes there. So that 30 must be here. So let's put that in there. So that 30 represents all three devices. Now we go to the next one, and I'm just going to tick this one. So now I look at this 35. The 35 own tablets and laptops. So that means tablets and laptops, that is the intersection, that must be a total of 35. But as you can see, we've got 30 already. So please don't make the mistake to put the 35 here because the whole thing must be 35. So that will then be 5, which will give us then the total of the 35. So now we go to the next one, that we are done with the 35. Now I look at the 50. The 50 own cell phones and laptops. Now, if we go to this one, cell phones, laptops here, so that is the intersection, and that must be 50 in total. We've got 30 already, so that means we put 20 here. So let's just put the 20 down there, and as you can see, this now add up to 50. So we are finished with that one. So now we look at the 40 who own cell phones and tablets. So that is now cell phones and the tablets. So it's this intersection. And that must be a total of 40. So that means this part must be 10 so that they add up to that 40 that was given to us here. So that will be 10. So now we are finished with the 3 events. These represents only 2 of them, 2 events, and now for the single ones, and that is cell phones. So how many own cell phones only, tablets only, or laptops only? And that we will get from this 125, the 47, and the 58. So let's start with the 125 who own cell phones. So it is important to take note that 125 is not here. It is the whole event that must add up to 125. And as you can see, we have 40 plus 20 is 60. We have 60 already. So here, this must then be 65 so that they will add up to the 125. So let's put down 65 in that one. So that means we are finished with the 125 and now we go for the 47. And that is the 47 people who own tablets. So that 47 tablets is this whole event again. We have already, if you add these 3, we have 45, but the total must be 47. So that means we're still short 2. And that means that must be 2. So if you add them, you can see that it's the 40 plus the 5 plus the 2 that gives us the 47 we need. And now we are done with that 47. So now we're going to look at the last one, which is the 58 who own laptops. Now, if we look at laptops, this must be 58. As you can see, we've got 55 already. It must be 58, so that means we still need to put down 3 here. So let's write the 3 down, and if you double check this now, the 20 plus the 30 plus the 5 plus the 3 gives us the 58 that we need for this one. That was the 58. So the very last thing before we start looking at the questions is we need to determine if there's maybe anything outside. Don't just assume there's nothing outside. You must be aware that there it was given to us that there are 150 teenagers that were surveyed. So that is our sample space. So that 150 represents the sample space. So that means if we add everything inside here and we don't get 150, then it means we need to find what is outside. Now, if we start adding them, then you will hopefully see that we will get a total, and you can use your calculator or if you want to do it mentally, but it is fairly straightforward just to add all of these and to see what you get and to see what we still need. And that what we then find that we will put outside means that those teenagers own none of these devices. So this 30 own 3 devices, the 10, the 20, the 5 own 2 devices, and the 2, the 65, and the 3 own 1 device only. And now we want to find how many own 0 devices. And that is 150. Subtract all of these that, and you can check, and hopefully you agree with me, we will be left with 15. And now to see if we are correct, if you now add everything, including the 15, we hopefully will get this 150 that we said is our sample space. So that means our Venn diagram is now finished, and we're going to use this Venn diagram to answer questions. So if we look at the first question, and in this question, they ask us, how many of the teenagers surveyed own cell phones only? Now, it's extremely important to read this carefully. The question is how many? And this how many is applicable to all 5 of these questions. Remember, how many means a number. So they are not asking us to find a probability. They ask us just a number. Now, those numbers inside our Venn diagram, that is what we're going to use. We just need to find where we will get it. So where do we get cell phones only? So if I go back to the Venn diagram, you will notice that this whole thing represents cell phones. This one. But we want cell phones only, and I hope you agree with me, that will be the 65. So the answer for this first question is just 65. Very straightforward. Just read your questions carefully and be very aware whenever they ask for how many or if they ask for probability. We are going to do a few on probability as well. But for now, we only want the number. The second question, cell phones and laptops, but not tablets. So that and refers to the intersection. So if I go back, cell phones and laptops. So cell phones and laptops, that is my intersection. So you can see there's 50, but they say we must exclude the tablets. So we must not, this is part of cell phone and laptops, but that is also part of tablets. And the question was cell phones and laptops, but no tablets. And I hope you agree with me. Our answer will be 20. So if I go back, then I can say that this one must be 20. It's cell phones and laptops, but no tablets. In the third one, they ask us exactly one of the 3 devices. So I want you to be very careful here. They say exactly one of the 3. Now, when I go back to the Venn diagram, you need to know which parts of this drawing represents one device only. And I hope you agree, the 65 represents those teenagers that own cell phones only. The 2, that is the ones who own tablets only. And the 3, those are the ones who own laptops only. So that means we're going to take the 65 plus the 2 plus the 3, which is equal to 70. So this answer then will be 70. And that is exactly one of the 3. So we only want those who own one device only. In our next question, they say exactly 2 of the 3 devices. So that means we must go back to our Venn diagram and see where we will find exactly 2. So that is the key, the exactly 2. That one was exactly 1. Now we look at exactly 2. So if we go back to the Venn diagram, we want to know which parts represent exactly 2. So you hopefully agree with me that this is the intersection between cell phones and tablets. But this 30 is part of 3. We only want those who own exactly 2. And I hope you agree with me, that will be 10. This 10, they own cell phones and tablets only. This 20 owns cell phones and laptops only. And the 5 own tablets and laptops only. So we're going to take the 10 plus the 20, which is 30, plus the 5, which is 35, and that will be our answer for the exactly 2, and that will be 35, if I can just write that down. Good. Now, the last part of this B, and we are still busy with the how many. So it's very important that you are aware of what exactly they want. There's the big difference between how many and probability. Remember, probability, we must divide with the sample space. So in this one, we read that at least one of the 3 devices. Now, you must be very careful with the language here. When they say at least one, what do they include and what do they exclude? At least one means it's a minimum. We want from those people who own 1 device, those who own 2 devices, and those who own 3 devices. That means at least 1. So it can be more, but it must be at least 1. So the only part that is excluded, if we go back to the Venn diagram, will be this 15 that is outside. So at least 1 means those who own 1 device, those who own 2 devices, and those who own 3 devices. That means at least 1. So we must add up everything inside, which we did before when we calculated the 15. So this answer, quite easy, is just the 150. Subtract the 15 will give us that total, or you can just add them. So that answer, I hope you agree with me, will then be 150 minus the 15, which is 135. So that is the number of teenagers that this 135 that own at least one of the 3 devices. Now I want us to move on to the C part of this question. Now in C, they ask us if 1 teenager is selected from the group, what is the probability? What is the probability? So that is extremely important that you don't miss that when you do these questions. The previous one was how many, and now that was the how many. Now they want probability. Now I want you just to remind you of our definition or formula to calculate probability. So the probability of any event is the number of outcomes in that event over how many in the sample space. Now, the Venn diagram gives us that, how many in the event. But we must divide with the sample space, and that sample space was given to us, and that is that 150. So with these ones, every time we will divide by the 150. So let us now just look at this first question. What do they want us to find? We want the probability when none of these teenagers, no one own any device. So none of the 3 devices. Now I think it's quite clear where we will find this on the Venn diagram, because that 30 owns 3, 10, 25, the 20, the 10, the 20, and the 5 own 2 devices, the 65, the 2 and the 3 own 1 device, and the 15 own no device. And I think you agree that is the answer that we want for this one. So no device is then the 15, but please remember, you must divide by the sample space, which is 150. And then a good habit is to simplify this fraction, which is pretty easy, and it will give you an answer of 1/10. So this is a probability. Remember, probability can never be more than 1 and never less than 0. Right, our next question is at least 2 of the 3. So this one was none device, no device. This one is at least 2 of the 3. Now, when we say at least, like I said before, that means that is the minimum. So we don't want to include those who own 1 device or 0 devices. If we say at least 2, then it means those who own 2 devices or 3 devices. So let's look at the Venn diagram where we will find it. Now, I hope you agree now that this 10 owns 2 devices, 20 2 devices, 5 2 devices, 30 own 3 devices. Remember the question said a minimum of 2 devices. So that means we must add these numbers. The 10 plus the 30 is 40, and that is 60, and plus the 5 will give us the 65 we are looking for. So if we write that down, then what we have is we have the 65 over 150, and now it is not too difficult to simplify this fraction, and you can check and see if you agree with me. I get an answer of 13 over 30. So that is the probability that when one person is selected, that person will own at least 2 devices. So now for our last question in this example. This question say at most 2 of the 3 devices. So we don't want more than 2 devices, but we want less, because at most means it's a maximum. 2 of the 3. That is what at most means, not more. We want 2 or less. Now, when we go back to our Venn diagram, you will agree that 30 represents 3 devices. But we don't want 3 devices. We want at most, we want those who own 2 devices, so or less. So we want the 2 devices, those own 2 devices, 1 device, but we also, very important, include the 15, and that is the 0 devices. Remember, it was a maximum that was given to us. So it means we must add the 65, the 2, the 3, the 20, the 5, and the 10, and the 15. So that is what we need to add, or even easier, everything except the 30. Now, everything inside here add up to 150. That you will remember. But we don't want that 30 because those 30 own 3 devices. So I hope you agree, and you can double check. They will add up to 120 then. So our answer for this one then is 120 over my sample space of 150. And this is not a very difficult fraction to simplify, and it simplifies to 4 over 5. So that is our probability that at most, if we select someone, that person will at most own 2 of the three devices. So this is our first example on the Venn diagrams on two events. No, rather three events. We already finished with the two events. And I would like us to discuss another example on three events, Venn diagrams. Let's look at this next example. This problem says that most of the grade 11 learners from Freedom School make use of public transport. There are three available modes of public transport, and they are buses, minibus taxis, or trains. There are a total of 100 grade 11 learners, of whom 29 use buses, 62 use minibus taxis, and 40 use trains. 12 use buses and minibus taxis, 22 use buses and trains, 17 use minibus taxis and trains, 13 don't use public transport. So you will agree when we look at that 13 that doesn't use public transport, you agree that will be outside. The first question is, let the number of learners who use all three modes of public transport be X. And you will remember from our previous example, we said that we always want to start with that middle. And the middle was not given in this information, but they say to us we must call it X. And then we must represent the information on a Venn diagram. So let's just draw the Venn diagram. Remember, this Venn diagram have three events. That's my sample space. And then the three events. So this one I'm going to name it B for buses. And then the next one for the minibus taxis. And then T for train. Now, what they told us here is that those learners who use all three modes of transport, we must call X. So this part will be X. And now we're going to look at what the other parts, what they all represent, and also what is outside. Now, I want to go for now straight to the outside because this in this particular problem was given to us as 13. So my 13 goes outside. So that means I've got that one. So now when I look at the next one, and I'm just going from the bottom up, I'm going to look at the 17. Use minibus taxis and trains. So 17 use minibus taxis and trains, these two. So that 17 is this whole thing. But that is X already. So because we don't know what X is, we now need to write this in terms of X. And then it means it will be 17 minus X. The next one, we are finished with that. The next one is this 22. Those are 22 learners that use buses and trains. The 22. So this 22, buses and trains. So this whole thing is 22. So that one will be 22 minus X. So let's put that in 22 minus X. And then, of course, we're going to look for that one. So we are done with that. And now we go for this 12. 12 use buses and minibus taxis. So 12 use buses as well as minibus taxis. So it's this part. And there's X already. So that will be 12 minus X. So we put in 12 minus X here. We are now finished with all of these in terms of X. So the next thing we need to do is to find this in terms of X, this one on minibus taxis, and this one on trains. And that we will get from that first one that was given to us. So let's start. There are three of them, and we will do them one by one. And this one is the 29 use buses. So we want to start with that one. So I say 29 and I'm going to subtract. And what are we going to subtract from the 29? We're going to subtract this 12 minus x, the x, and the 22 minus x. I'm going to subtract all of them. So let's now just write it down. 29 subtract 12 minus x. It's important that we put this in brackets. Subtract the x, subtract in a bracket again, 22 minus x. And then we're going to remove these brackets, and please don't make sign mistakes here. So it's minus 22 plus x. And if you simplify that, you will get x minus 5. And that x minus 5 goes right here. So we are now done with the 29. So now we are going for the 62 minibus taxis. Now, minibus taxis is this whole thing. So we're going to repeat this. We're going to take that 62, subtract this x, and subtract the 17 minus x. So let's write that down. So the second one is 62, and I subtract 12 minus x. I subtract the x, and I subtract the 17 minus x. We can now remove all the brackets and then simplify to get our answer, which is 33 plus x when you simplify all of that. So that 33 plus x will go right here, 33 plus x. That is where we will write that down. So now we've got only one part left here, and that is now the part where we are looking at the trains, the 40 trains. So we're going to say that 40 minus 22 minus x, minus 17 minus x. So that is then the 40 trains in total. Subtract 22 minus x, subtract 17 minus x. And if we simplify that, I get 40 minus 22 plus x minus 17 plus x. And that will give us 1 plus x. And this is then 1 plus x. So now we are finished with this Venn diagram. But as you can see, we've done it in x. So you can now already expect that in the next question, they're going to ask us to find x. So let's see if that is the case. In this question, they ask us to solve for x. Now, how will we solve for x? We are going to take this one plus that, plus 22 minus x, plus this one, plus this, plus the 13. Remember not to leave this out. And that must give us a total of 100, because that is our sample space, is 100. So let me just highlight that part. So we're going to write down an algebraic equation here, where we're going to add all of them, and we're going to put it equal to the 100 learners in total. So let's write that down. So we have x minus 5 plus 12 minus x plus 33 plus x plus 22 minus x plus the x plus 17 minus x plus the 1 plus x, and then still the outside of 13, and this must equal 100. So you can see quite a long problem. And now we just simplify this, and this will give us, if we look at all the variables first, the x. So that will leave us with x, because you can see this x minus x subtract to 0, this x minus x subtract to 0, and that minus x plus x subtract to 0, so we only left with this x. So that is where I get the x from. So x then, and in terms of the constant values, that will add up to 93, and that is then equal to the 100, which is our sample space. So now we can solve for x, and we say that x is equal to 7. So that was the question in the B part, that we need to find this x. Now, if I just go back to this Venn diagram, once we know what x is, you will agree with me that we can now find the values of all of these, because that x is 7, 7 minus 5, 12 minus 7, etc. So it is not too difficult. So I'm just going to draw a Venn diagram again here, and I'm going to then substitute all those x's by 7, so that our drawing is then ready to answer these final questions. So you'll remember this was event B for buses, minibus, taxis, trains. The middle was x, and we calculated x to be 7. This one was x minus 5, so that is equal to 2. And this part was the 12 minus x, and 12 minus 7 will give you 5. And this part of 33 plus x, and x is 7, will give us 40. This one was 22 minus x, and so it's 22 minus 7, gives us 15. This part was 17 minus x, and x is 7, so this part is 10. And then the last one is the 1 plus x, so which is 8. And you'll remember it was given to us that we have 13 outside. So this is now where, after we substituted in the previous diagram, so in this diagram, I substituted every x with 7, and I've got now my how many in every one of those parts. So we are now ready to answer these last few questions. They say to us that a grade 11 learner is chosen randomly. Determine the probability that the learner uses buses and minibus taxis, but not trains. The important thing is first of all to take note that they ask for probability. So that means we're going to divide with a sample space. So we can already say that the probability of this event, and we can put 100 below the line. So we only need to find the numerator now. Now, where will we get this numerator? That is the part which is buses and minibuses, but no trains. So the intersection between buses and minibus taxis is this whole thing. But they say we must exclude the trains, which is the 7. We must not use the 7 because that's part of trains as well. So it means it will leave us with a 5 only. So this answer will be 5 over 100, which we can then simplify to 1 over 20. But always important to look at, do they ask us for how many, or do they ask us for probability? The next question, they say, what is the probability that a learner uses only one mode of public transport? Only one mode. So we can say the probability of this event, and we're going to say 100, that is my sample space. And now we need to know, where will we find one mode? And you will agree, if we start in the middle, that 7 represents all 3 modes of transport. The 5, the 15, the 10, 2 modes of transport. And the 2, the 40, and the 8 represents 1 mode of transport. And the 13 use no public transport. So we're going to take the 2 plus the 40 plus the 8 to find this probability. So it's 2 plus 40 plus 8, because they represent only that one mode of transport. And this, you can see, gives us 50 over 100, which is the same as a half. For the last question, they ask us to find the probability that a person uses more than 1 mode of public transport. Now, it's very important to take note which parts are we supposed to add here. They say to us quite clear, uses more than 1 mode. More than 1 mode. Now, more than 1 mode means we must exclude those 3 as well as this one, because this is no public transport. These ones use 1 mode of transport. More than 1 mode will be this, plus the 7, plus the 10. So let's just write it down. So the probability for this event, our sample space is 100, and we're going to say 15 plus the 7 plus the 5 and plus the 10. So it is now the 15 plus 7 plus 5 plus 10. And when we add those, we will get to 37 over 100. And as you can see, we use now our Venn diagram to find all these probabilities. Thank you.